In this JavaScript course, you'll learn how math can make your code better, simpler, and less prone to bugs. While building a fun project, Dr. Radu will teach you about procedural sound generation and techniques to enhance code readability and structure. If you've ever doubted the role of math in programming, this video will teach you just how powerful it can be.
I found this cool YouTube channel with a lot of so-called polyrhythms. They're simulations where balls make some kind of noise when touching something. I thought it'd be cool to recreate one of them, especially because I can use it to teach you many things about procedural sound generation, improving code structure, and how knowing a bit of math can make the code base much easier to understand. If you're one of those who think math is not useful when coding, this video is for you. Try to follow along. It's a nice project, I think. A change of tune from other things on the channel. Get it? Change of tune. So then, no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
We'll start in an empty folder. I have my Visual Studio Code editor ready here, and let's create a new file called index.html. And in it, we begin with basic HTML. So first the doc type, then the HTML tags, and the head. Let's add the title. It's going to be polyrhythm. And in the body, we are just going to have a canvas element appearing there. Let's save the file and open index.html in a browser to test. I'm using Google Chrome here, and you can see the title appearing here in the tab, but the canvas is not appearing there unless we open the developer tools and notice it in the elements. So let's make it visible. At the moment it's transparent. I'm just going to give it a style with the background color black this time. And now if you refresh, you're going to be able to see it on the page as well. I'm going to make it bigger, and I'll do that in JavaScript this time. So let's give it an ID here so we can refer to it in the JavaScript code. And here, let me open a script tag and close it and define a size of 700 pixels and use that for the canvas width and the canvas height, like so. And now if we save and refresh, we're going to see it filling up more of the screen like this. You can use different value here if it looks better for you. And looking at that example that we want to follow, I see two essential elements there. A track on which balls are moving. So a track object and a ball object if you think about the object-oriented paradigm. So let's implement those objects and draw them on the canvas. And to do that, I'm going to move here and get access to the canvas drawing context, the 2D context. And let's assume that we already have a track object somewhere. It's going to be defined by a center. If we consider those arches are part of a circle, then that has a center there in the middle. And I like to use this circle for much of this tutorial because it's going to help teach you some things. So let's have them as circles in the beginning. And we need to pass a center for the track and a radius for the track. And then the track should also be able to draw itself on a given context like this. So I'm going to set the center of this first track to be in the middle of the screen, so half the size and half the size. And the radius, let's just set it to 100 pixels for now. And Now we can implement this based on what we need. It needs to have a location and a radius as a parameter and a draw method there. And we can do that in a separate file. It's going to be a little larger project this time. So let's separate some of the code. And you can create new files in VS Code by control-clicking it. It's generated here next to index.html, like so. So it's going to be a class, and in the constructor we are going to pass here the center and the radius. Let's set these as attributes so that the track object knows where it is and how big it is. And let's give it the draw method as well. On a context, we are going to begin a path and draw it using the arc method. So the arc method has several parameters. The first is the x location of where we want the arc to appear, then the y, so these are the x and y coordinates, and then the radius. And to draw a full circle, we can use 0 for the beginning angle and 360 for the end angle. So we could put here pi times 2 because the angles in the arc method are specified as radians. Now, to see it appearing there on the black canvas, let's set the stroke style to white and stroke. Now we can test real quick. Let's save and refresh. And you can see a circular track here. If you're going to pass here just pi there, you're gonna see half a circle, and if you wanted to go that way, then you could also pass here true so that it goes counterclockwise. But again, I want to work with circles here for the moment, so this is our track. And let's define the ball on the track. So in index.html, we will need a ball object as well. And in this world, really, balls are stuck to their track. They can never go outside of it. So it makes sense to somehow pin it on the track in some way. And that's why I like to define the ball here as a new ball on the track and then pass some properties like how big it is and how fast it moves. They seem to be moving at different rates. So let's say ball speed also is important here. And then after drawing the track, we can also draw the ball in a similar way. Let's define this ball radius, maybe 10 pixels, and the ball speed. Let's just have 0.1 for now. And now I know what we need. We need a ball with 3 parameters in the constructor and the draw method. So I'm just going to copy this, rename it to ball, and control-click to create a new file. And a very similar class ball this time. Now the constructor has the track, the radius, and the speed. And this track, setting it to track, storing all the attributes from the constructor here so that the ball knows what they are. And let's say that in the beginning, the ball starts at the beginning of the track. So we will control that with an offset parameter. But to draw the ball, we need to have an X and Y coordinate for the ball. And at the moment, we don't have. What it can tell us, the XY coordinate, is the track object. It should be able to tell us because it decides where the ball is going to go. So I'm going to get the center of the ball by asking the track to give us the position at this offset. And now we can implement this draw method on a given context where, similar as before, we begin a path and use the arc method to draw a small circle this time at center X, center Y, with this radius 0 math pi times 2. Let's also have it a white stroke for the moment, and then stroke. And all we need is this getPosition function here. So let's go to track.js and implement a way to return the position according to an angle offset. So this is essentially converting from polar coordinates, because we know the radius, we know the center, and we know this angle offset there. We are getting the xy value. Like so, using the cosine of the offset for the x. And for the y, I'm using a minus here because I want it to start going upwards. But other than that, it's essentially following the unit circle. And now if we save and refresh, we see the things there. A lot of work for just 2 circles appearing on the screen, right? I mean, if you just want to draw 2 circles, you can do it with a couple of lines of code. You don't need all this crazy stuff. But there's a reason for the structure, and I'm going to explain it soon. First, let's just get animation out of the way as well. So let's implement the ball moving according to its speed along the track. And here in index.html, let's go below these objects and animate, and define an animate function. First, it's going to clear the canvas. So let's remove everything that is there. And now redraw the track and the ball on each frame. And then call the request animation frame method, passing animate as the parameter. This is going to call itself again and again as many times as possible per second. But the ball should also move before we attempt to draw it. So let's go here and say ball move. And this needs to be implemented next. So inside of this ball, define a move method like this. And we increase the offset with this speed. So this is in angles, really. And then we have to update the center by asking the track to tell us where is the XY position according to this offset. Now, if we save this and refresh, we get the ball that is spinning along this track. And again, very complicated code to do something like this. Why go through all this trouble with this structure and asking the track to give the position and the ball and so on, instead of just drawing 2 circles there with some kind of a update in the angle? So the real reason is that in this way, you can have more flexibility. You can generate any kind of track. And now we are deviating a little bit from that example, which had just a half circle track there. But anyway, I think that this is very important for you to realize that structuring code a certain way gives some kind of flexibility. And I'll show you. Here we are using the circle equation, one of the circle equations. I already have a video where I show you 10 ways of doing it. But this way we generate a circle here, and we also draw the circle here, but we are cheating. We're using the arc method. Really, you could use the same technique here by drawing many small lines along the circle points. So let's try doing that here. I'm going to loop with an angle starting at 0, going to 2 pi, so a complete circle. And let's increase it by a small fraction like this. Let's do line 2. And here we write the same formula, because we are converting to get an x coordinate and a y coordinate. It's essentially what the arc method is doing there. Of course, it has many parameters, so you could set 0 and 2 pi to something else, but anyway, let's save this and refresh. And you can see it's almost a circle. It's not closing here. You can do that by adding here a close path at the end. So it connects again to the beginning. And it's jagged. It's jagged on purpose because I wanted you to see that we are really drawing it here, and you could make it more refined by setting a smaller value there. So now it looks essentially the same as before. And this is the math that generates that specific path. But you can generate some other path. Like if you take here A and multiply it by 3, the path is going to look like this crazy thing. And the reason the ball doesn't follow the path is because there's now a discrepancy between this code here and this code here. You could get this one to act in the same way by doing this fixing. And now the ball is moving there. Maybe a bit too fast. Let's slow it down a little bit and give it maybe 0.01 here. And now you can see it following that shape. And this is a problem. I mean, why have this copied code here for drawing the path, drawing the track, and getting the position when you could use get position? And this is something really important. Reusing code and avoiding duplicates is really important. So let me teach you that. We can get here the position by calling the same method we have above with a as the parameter. And then here in the line 2, we can just use the position x and position y like so. And now these are in sync. So if I'm going to restart, it works, no surprise here. But if I'm going to change this formula to something else, like maybe this, then it's even more kind of looks like a DNA strand. It's in sync. It's behaving as we expected. Now this looks a little bit jagged here, so of course you could add more detail like so. And I hope you get the point. But you can play with these crazy patterns all you want. I'm not going to focus on them. I'm just going to leave you with this example code and revert to the circle equation. So we have the same thing as before, written in a fairly complex way, but there is this flexibility there. And the fact that the track tells you where the ball is going to be means that the ball doesn't need to change its implementation. It just relies on the track. And also really important is you could have multiple tracks. You could imagine different formulas there defining the paths, and you can switch through them and implement different applications really easy if you have a good structure like this. But in that example, this ball was going here and then bouncing back. So the direction would change, the movement direction would change. And let's implement this in one way, and then I'm going to show you several other ways that are actually better, and we have a lot of things to learn during this process. Now, what most people would do in this case, if the ball has to change direction, it's that they would add here a way to mark which direction the ball is moving in. And I'm going to use 1 and -1 to indicate this. And really, here when we update the offset, we could say multiplied by this direction, and that's going to solve our problem. But we also have to change the direction somehow. And I'm going to do it here and say if this center y, the ball's y, is going to be greater than the track center y, then we switch the direction. So we multiply it by -1. Now if we save and refresh, the ball is moving and then moving back. And then here moving back, because this direction has changed when the ball goes below that kind of horizontal line appearing there. So we already have a functionality that is very similar. We're just missing the sound. And let's generate that as well. It's going to be played here when we change the direction, basically. And let's go to index.html and create a file for this sound as well. Maybe sound.js. And control clicking this gives us a new file where I'm going to use the web audio API. So generating a new audio context, supporting Safari as well. And let's create a function for playing the sound. It will need to have control over the frequency. Let's set the default value of 440 and a duration of 1 second. These are very often useful parameters when working with sound. And to generate sound, we can create a basic oscillator like this and connect it to the destination. This means to the speakers. And let's set the frequency to this parameter at the current time. So this oscillator is going to start with this given frequency. And we start it, it begins to oscillate, to play the sound, and we can stop it after the duration. Refresh. And here, when it changes direction, we should hear a sound, but we don't. And if we open the console here, we see that this audio context was not allowed to start. Because you need to somehow interact with the page before it starts working. So if I click the page now, it generated the tune there. A 1 second tune at this frequency. I'm going to refresh the page so it doesn't beep while I talk. And let's make this sound a little bit nicer. I'm going to add to this an envelope where we can control the gain. What I want to do is start the sound off at 0 loudness and then increase and then go down in a linear fashion until the duration ends. So I need to duplicate this line and connect the oscillator to this envelope, and the envelope will be connected to the audio context destination or the speakers. And now this envelope here, we can set its initial value to 0 at the current time when it was defined, and now quickly ramp up to 1. And it's going to be at the current time plus a very small fraction of a second, a fifth of a second. And then going back down to 0 after the duration. Doing this, starting at 0 and ramping up quickly, prevents a click that appears in the beginning of the sound. So now I'm gonna have to click on the page to hear it. And it's a nicer sound. Let's try making multiple tracks and multiple balls next. So in index.html here, we can prepare for that and say tracks is an empty array, balls is an empty array, and let's say we want 20 pairs, like this. Now we can loop, starting at 0 all the way to n, and the track radius is going to change. We can't rely on this fixed value anymore. but there is a pattern to them. It starts off at the minimum track radius and then increases at a fixed step. So all we have to do here is rename this to min radius and then track step, let's say 15. And now we can take these objects from here, move them here, align them a little bit, and add them to the tracks and balls arrays. So let's do it like so, and like so, and let's close this. And for it to work, we also have to consider that now track and ball are variables local in this scope, and we can't have this code here anymore. We have to rewrite it so that we draw, move, and draw each of the tracks and the balls. So we can do that using for each, and then draw each track like so. And the same thing for balls. First we have to move each ball and then draw each ball. I'm just going to duplicate this and copy this here. And now we can test. So save. And we get this. And the balls are all moving at the same speed. This is something we need to fix. There would be also sound, but I'm not clicking on this yet. Let's change the ball speed in the same way that we handled the track radius. So it's going to start at the minimum speed and increase by a ball speed step. So up here, ball min speed, and then the speed step is going to be a small decrease. And now the balls are arching like that. And if we click, we get sound, but they're all the same frequency. To have different frequencies, I generate here an array of frequencies that I think sound nice. So I'm just going to paste them here. You can get them from the video description. And we have to pick one from this array. So let's go here and say that the ball sound frequency is the sound frequencies of I. And we need to pass this one here. So when creating the ball also needs to know how it should sound like. So we need to change the ball constructor to accept a fourth parameter, sound frequency, and let's set it here below the speed. And we need to pass this sound frequency when playing the sound to override that default parameter. Now let's test. And click. Something is not right. There is a problem in the sound because we set all of the sounds to maximum value here. And when they are on top of each other, they're going to exceed that maximum value and it doesn't sound good. So one way to fix this is to give it a low value because we are expecting here to have multiple sounds overlapping at times. So this is going to make it sound better. I'm going to click. Yeah, no more problem here. But I think the duration could be improved, maybe 2 seconds. And clicking, Okay, nice. And let's have it play a little bit. And notice what happens here. You see this behavior? This is not what was happening in the application we tried to replicate. And the reason for that is very technical. Here, when moving the ball, it sometimes moves below the track center, so that horizontal line where it changes direction. But some balls move more than others. And because of that, they don't travel the same distance. What should happen is they should never move below that line. But we should interpolate, figure out where it touches the line, and then already reverse and move it a fraction in the opposite direction. And that would solve the problem. But you can probably see that there is a lot more code going into this strategy to solve the problem. So I'm going to show you another way to simplify the logic and to get it to work as expected in another way. First, the more creative way, and then the more mathy way. The creative way, I mean, the sound that the balls will play is actually the same if you would look at this animation here, or if the balls would just do full circles and generate the sound when they touch that horizontal border. Think about it. It would generate exactly the same sound. So for the moment, let's not bother with this back and forth and try to figure out how to do that, how to generate the sound on each round, so to speak. So this would be one round, another round, another round, another round. We need to detect when the round changes and then generate the sound. So a little bit different logic, I hope you're able to follow, but basically, instead of having a direction here, we won't. They will always go in the same direction. But they need to know which round they're in, because if it changes, they play the sound. So how to do that? Well, the best thing is for the track to give us the information on which round we are currently at, because it knows according to the angle offset. So let's go to track.js. And here we need to know that a period of pi, so half of the circle, is when the round changes. So I'm going to go here and say this period is going to be just pi. And when we get the position here, we can return also the round as the offset divided by this period. We only need to keep this integer value here, and I'm missing a comma. And now with this information, the round information coming from the track, we can go back to ball. And here, instead of getting this position and assigning it to center directly, we can say the result of this get position call is stored here. And then the center can be the X and Y of that result as before, essentially. But we also have another piece of information here. We can use if the result round is not the same as this round and replace this if statement, which is strange. I mean, look at the logic here, how complicated it is. The ball needs to know that the track has a center and a Y. And it also needs to know that that Y, when the ball exceeds that Y, something has to happen. And now we don't have to deal with that logic anymore. We just rely on the track to tell us when the round changes. And then direction is unnecessary anymore. We were supposed to remove it from everywhere, also from here. And the only thing we do is play that sound and also update the round in this case. So like that. And if you save this and restart, and now just click somewhere, the sound is appearing there. The animation doesn't look good. But the sounds that are playing are actually the same as they are supposed to be. Now, no more problem with the strange distribution of the points that we saw previously, because now everything is moving at the same rate all the time and there is no glitchy effect happening because of that change in direction. So we solved that problem and the sound is fixed. But the visualization should jump, right? And I'm gonna show you a trick to solve this problem, and it's by drawing the ball twice at a symmetric position relative to that horizontal line there. I'll show you. So what we do here is we can generate a fake Y location for the ball, symmetric to the track center Y and relative to this Y. And then we can duplicate this code. I'm just going to draw it twice now, so that one of it is at this fake Y. So let's keep the original one here and the fake one here. And now let's see what we get. It looks a little bit strange with symmetric things up and down like this. And I'm not playing the sound now so that you can hear me speaking. But let's see what happens if I'm going to change here the size, the canvas height. Basically, I'm gonna half it. So we only see the top part now. And look what happens here. It kind of looks like the balls are bouncing in the other direction, right? Let's actually shrink this track a little bit so that we see it all like in that example. I'm going to set here the track min radius to maybe 50. And now everything looks nice here. So look, they're bouncing with a little bit of a glitch effect at the end, because you can see somehow the other balls as well. But you could get rid of that. Like if you go here when drawing the ball and only draw one or the other depending on its Y value. So if the fake Y is greater than this center Y, then let's leave this code. Otherwise, we draw the other. So if the fake one is below, then we don't draw that one. And vice versa. And now we get pretty much the same as in that example, and the balls seem to bounce, and we have the effect that we want. If I'm gonna click here, the sound is also going to come. And there are no more those problems because of the complex logic that wasn't yet perfect. Okay, so we got it to work. It can be done much simpler than this. All you need to know is math. And this is an example again of useful things you can do with math if you know it, and how it can simplify some logic. If we remove this crazy thing with the fake Y, I mean, it's also hard to explain what is that fake Y in the code. And yeah, the ball should be just a ball. Complicated the logic here, and for no reason really. You could have taken out that complex stuff, maybe here to index HTML, and maybe clone balls here. That would have been a way to generate them symmetric along the track so that the ball logic doesn't become complicated. So on second thought, this would have been a better place to do that. But we don't have to do that at all. We can just keep the logic here like that and tell the track that we want to generate a half a circle, not a full circle. And you do that by adding here an absolute value to the sign. And that's it. If you refresh now, you're going to see these balls bouncing there, going back without that fake thing. And actually, let's go back here and set the size of the height of the canvas to the full size. And you'll see that we are drawing half circles now. But it's not really true. We are drawing half circles and then half circles back. Because the absolute value for the sign makes all negative values, these ones here, positive again. So they essentially reflect back up. And with this one line change there, we get exactly the behavior that we need for building this application, without complicated things like direction changes and so on. The track now actually looks like that and then goes back. And this loop is periodically infinite. We're ready to style things, I guess. Let's reset here the size to half, because that's really all we need. And we need to generate colors. I'm only going to worry about the color hue here. So the hue is going to be defined like this, a fraction of 360 depending on the value of I. And we need to pass this one to the tracks, they will be colored, and also to the balls, they will be colored as well. Let's save this and start with the track. Pass here the hue as well. And after the radius, let's set the hue value like this. And now the stroke style here, I'm going to use a backtick, because I will define a color in this HSL format. And I want to pass here this hue using this syntax. And then the saturation 100% colorful and the lightness 50%. Because 100% would be white, 0 would be black, so 50% gives you the color that you need. And then let's close the backtick. Now if we save and refresh, you get here all the hues, and if you don't like these specific ones, you can go back here in index.html and play with this formula. But I'm happy with that. And let's move on to make the ball as well. I'm going to go here and let's pass hue. And after the sound frequency, the hue gets stored as well as an attribute. And now the stroke style is actually white in that example, but the fill style is what needs to be defined, and it's the same formula from before, but assigning it to the fill instead. And then let's fill. And now it's nice, but maybe this stroke style could be, the line width could be a little bit bigger and the balls should be smaller. So let me go up here and say line width set to 2. And in index.html, where we specified the ball radius, maybe a value of 6 is better. Okay, and we're almost there. Last thing is, when the balls touch this bottom part, they need to change to white and then gradually go back to this color. So we need to somehow measure the progress along each round. And let's go to ball.js and prepare to do that here. So the progress, let's set it to 0 in the beginning. And we will have it being returned by the track because it knows what is the progress there. So let's just take it like this. And we need to modify get position in the track to give us also that. I'm gonna do it real quick here. So the progress, now we take the remainder when dividing by the period. This gives us a value between 0 and the period. So I would like the progress to be between 0 and 100% or 0 and 1. So let's divide by the period as well. And let's save this. And now back to the ball, we can use this progress for the lightness value here. So let's have it so that it becomes 100% minus that progress times 50. So this is going to give us between 50 and 100% if we just enter it here like so. Let's save. And they change from white to their original color, and then they bounce back with the new color. Really nice. So now it's your turn. Try to make this even more special. Maybe play with the math formulae and do something cool. Show me if you happen to be on my Discord. And now maybe let's just listen to this application one last time. So refresh, and I'm gonna click once. And thanks for watching. See you guys.